Hello everyone, this is Chris back again with The Ancient Scholar, continuing on our lines of discussing conversions. And what I'm going to do is I'm just going to stick with the same theme from the last video. This 100,000 gallons of water comes to your treatment plant per day, and I want to work through a few more conversions just so we can kind of get a hand on what questions are asking, what factors we need to use. And I would absolutely recommend that you guys go through your book and you find out, these real common conversion factors. I would assume that the 1 U.S. gallon equals 8.35 pounds would be a pretty critical conversion factor that you'd want to have. Other conversion factors would be different kinds of weight, different kinds of volumes, flows, I would presume, so on and so forth. But certainly you need to have these conversion factors to actually set your formulae up. On a side note, I do find it interesting that they talk about converting gallons and pounds and liters and so on and so forth. Again, coming from medicine, I find it very inconvenient working with imperial-based systems of measure, and the U.S. system is an imperial-based system. It's much more non-intuitive converting when you talk about gallons and miles per hour and pounds and things like this. They're very non-intuitive conversions, whereas in the metric system, when you talk about liters and milligrams and grams and kilograms and so forth, you're generally talking about, how many zeros, what way am I moving my decimal point, up, down, to the left or to the right. And that, at least in my mind, is a lot more intuitive, and perhaps it is more intuitive in the water realm, because I'm not educated in water technology. But certainly, from an intuition standpoint, going back and forth between an imperial system and a metric system is certainly probably can be very frustrating. So my heart goes out to you guys that have to do that with a fair amount of consistency. All right, so let's go ahead and let's give you guys another question or another problem. And let's just say that for every gallon of water that comes to this plant, we know that 100,000 gallons, and we know that every gallon has about 500 milligrams of solid matter in it. Solid matter dissolved in it. And now, I presume what they're talking about, again, this isn't an exact homework problem, but it's related to the homework. I presume what they're talking about is in every gallon there's a 500 milligrams of fecal matter, fecal coliform bacteria, what have you. That's the solid matter they're talking about. So for every gallon, 1 gallon, there's 500 milligrams of that gallon is the solid dissolved matter, fecal matter, or what have you. And what I want to know is how many pounds of solid matter go through the plant per day. Okay? Now this is a bit more complicated. Let's find out what it's asking. First of all, it's asking, or it's telling us rather, that we have 100,000 gallons of water. And then it's telling us for every 1 gallon there are 500 milligrams of solid matter, and we want to know how many pounds of solid matter is in this 100,000 gallons of water. Okay? So how do we make sense of this? Well, there are several ways we can go about doing this, but I'm going to show you one way. I'm going to go, well, if every gallon has 500 milligrams, let's start here. Okay? Because I know this, right? This is condition A. I know that beyond a doubt, that 1 gallon is 500 milligrams of solid matter. Now I have 100,000 gallons. Oops. And I don't know how many milligrams. So again, this just becomes a very simple process of cross multiplication. 1x equals 100,000 times 500. Again, if you're really good at math, you could just kind of do this in your head. I would recommend just using a calculator to double check. So 100,000 times 500, and that gives us, excuse me, 50 million. Million what? Milligrams. Okay, so now I know without a doubt, for a fact, that 100,000 gallons of water going into my plant is going to contain 50 million milligrams of solid matter. Hopefully that makes sense. So now what I need to do is I need to find a way of converting this into pounds, right? Because that's what they want to know. How many pounds, not milligrams. So then I need to look up a conversion factor, and I need to find out how many milligrams there are in a pound, right? How many milligrams are there in a pound? Because I'm converting milligrams to pounds. So I need a way of converting this to this. And that's how we need to look at these problems. You need to kind of pry them apart and whittle your way through them. So in that case, we know that 1 pound equals 453.6 grams. But is that what we want? No, we want milligrams. And we know that 1 gram is 1,000 milligrams, so 1 pound is going to equal 453,600 grams. Okay? So, now I have something to work with here. 453,600,000 equals 1 pound, right? Alright, so now what I'm going to do is I'm going to go, well, I know that. I know without a doubt that 453,600 milligrams equals 1 pound. And what do I have? Well, I've got 50 million milligrams, but I don't know how many pounds. So now this becomes just a bit more complicated, but don't worry, we'll work through it. So that tells us that 453,600 times x equals, cross multiply, 50 million. Now I need to get x all by itself. So I need to get rid of this 453,600 times x. So the way we do that in algebra is I divide. So I divide this side by 453,600, and x will drop down, right? X drops down all by itself now. But what I do to one side, I have to do to the other side. So I have to divide 50 million by 453,600. And let's go ahead and do the math. So 50, 1, 2, 3, 4, 5, 6, 50 million divided by 453,600 equals 110.23. I rounded it up. It's 110.2292768, etc., etc., etc. 0.23 what? 0.23 pounds. Pounds of solid matter. So there are just a little over 110 pounds of solid matter going through my plant per day. And a little more complicated conversion, but again, just work through every little bit of it, find out what they're asking, and you guys will be good to go. All right, thanks again, guys. Bye-bye.